Hello, it's nice to meet you in this nice live class we are taking today. Today we want to look at how we will answer some few exam questions. These are related exam questions. If you are taking questions related to Olympiad Maths, related to the Oxford aptitude test or Oxford exams, and more of the Harvard entrance exam or university exams, these are some of those few questions you might be asked, and these are some of those few questions we will want to answer. We are going to look at three questions that are most likely to be asked when you have exams like that. One of those unique questions that people do look for answers to are questions like this. You'll be asked to find the fourth root of x. If you're asked to find the fourth root of x equal to -4, and you're asked to find the value of x, what will you do? Now, this is one of those questions that many people find it very hard to get an answer to. But in the course of this live class, we're going to look at how we can get an answer to questions like this. And this is exactly some of those things we'll treat in this live class. So we're going to look at how we look at answers to questions like this, and those are some of those things we'll treat. Now, when you are given a question like this and you are asked to find the answer to a question like this, how will you go about doing it? We have the fourth root of x equal to -4. How do we find that? Now remember that according to the law of indices, if I have the square root of the nth root of a, this is simply going to give me a to the power of 1 divided by n, right? Good. Now, if I apply that here, it's going to reduce this expression. So from that expression, I'll have x to the power of 1 divided by 4, and that will be equal to -4. Now I can separate -4 to give me 4, or -1 multiplied by 4, and this will give me x to the power of 1 divided by 4. Yes. Now I've not done anything here. I'm only taking this, separated the -1 from the 4, and if you have -1 multiplied by 4, it's going to give us -4. Taking. Now if we do that, we know that 2 to the power of 2 can be equal to 4, right? Yes, 2 to the power of 2 can give us 4. And we know that from the complex numbers, from the rules of complex numbers, if I have -1, -1s can be equal to I, right? And then if I take the square of both sides, and I take the square of this square will cancel out this square, and then I square can be equal to -1, right? So wherever I see -1, I can simply replace it with I square, right? So this is going to give us x to the power of 1 I square multiplied by 2 square. Great. Now, how do we expand this in order to have a simplified solution? Remember, we're asked to find the value of x. Now, how do we simplify this? Now, remember a rule in indices that if I have an a to the power of x multiplying a b to the power of x, right? This can simply give me the multiplication of these two, all to the power of x, because they have same index, right? So if I apply that over here, I'll have my x to the power of 1 divided by 4, and this will be equal to 2i all what? All squared. Great. Now what do we do from here in order to find a value for x? Now this is where we are going to consider solving this. Now to do this, let's look at how we can take the power of 4 on both sides. We can multiply both sides by the power of 4. Now if we do that, our main aim is to clear out this 4 on the left hand side. Now if I clear out that 4 on the left hand side, what do I have? If I have this multiplied by 4, all of this multiplied by 4, and I have all of this multiplied by 4, This is simply going to cancel out this, and I'll be left with my s here, and this will be equal to this index will multiply the index out there, and I will have what? 2i to the power of 8. Does that give me the value of my x? Of course, yes. The value of my x now remain, x will now be equal to 2i, because if I don't put this bracket, it will be as if it's only the I that is carrying the power of 8. Both are carrying the power of 8, and this is the solution to this question that's given to us over here. Now the question is, how am I sure that this can truly be the solution? Now let's check. We're going to go through a process of checking in order to find out if this solution is actually right. Now let's look at how we check this. To check this, we are going to look at inserting the value of x, which is 2i to the power of 8, into the main question that is given to us. Now if we do just that, we are going to have the fourth root of 2i multiplied by the power of 8. Now, is that going to give us negative 4? Let's find out. Now, remember, according to the law of indices, this is going to give us 2 multiplied by I to the power of 8, and all that will be multiplied by 1 divided by 4. Now, will this be equal to negative 4? Now let's find out this. If we find out this is going to cancel out this 1, and this is going to give us what? 2. And above that, we are going to have that expression to now give us this. Let's clear off this. That expression will now give us this to be what we will be arriving at. That expression will now give us 2i to the power of 2, and this will be equal to negative 4. Now, will this give us negative 4? Let's find out. Now, if we separate this according to the law of indices, we'll have 2 to the power of 2 multiplying I what? I square, and this will be equal to negative 4. Now, will this give us negative 4? Remember the complex rule that if I have negative 1, the square root of negative 1 is equal to I, right? And if I take the square of both sides, then I'll have I squared to be equal to negative 1. So if I have I squared to be equal to negative 1, 2 to the power of 2 will give us 4. And when I multiply this with this negative 1, that is definitely going to give me negative 4, right? And so I'll have negative 4 to be equal to negative 4. And that tells me that x equal to 2i, which is all to the power of 8, is the right solution to this question given to us up here. So you see, when given a question like this, you look at it, and one of those things you must definitely strive to do is to see how you can clear the fourth root or the square root or whatever you have in order to simplify that expression. Now, this is the solution. Now let's look at how we can screw out this, and then look at another question that might most likely come up in your Oxford exams, Olympiad exam, Harvard University entrance test, or whatever. Now we have one other question that might intrigue you. And what is that question? You might be given a question like this. Let's check out this question. Now you might be given a question like this, and if you are given a question like this, you'll be required to find the value of x. Now, have you seen a question like this? The exponent value of x equal to x to the power of 2, and you are asked to find the value of x. Now, if you are given this question, how do you go about finding the value of x? Now, many persons will look at this expression and say, cool, all I need to do is to find out the value that will give me my x, and I will use some principles in mathematics. Fine. Now, one principle that will come to our minds is the principle that has to do with the Lambert W function. Now, you're going to see how we use the Lambert W function in finding an answer to this question. Now, how do we do that? First of all, let's see how we can simplify this expression. Now, to simplify this expression, all I need to do is to make the right-hand side to just have the x. All I need is to have the x. And what is the value of the x? In order to make the right-hand side have that x stand alone, all I need to do is to multiply both sides by 1 divided by half, the power of half. Now, if I do that, I'm going to have this expression to now give me the exponent of x multiply 1 divided by 2, and that will give me x to the power of 2 multiply 1 divided by 2, right? So by doing that, according to the law of indices, right, the exponents will have to multiply, and this will give me the exponential value of x divided by 2, and this will be equal to x. Great. Now, what do we do from here? In order to find the true value of x, and this cannot be the result of the value of x, I can't take that as a result because we need to simplify further. If we have x, exponential of the exponential value of x divided by 2 cannot give us the value of x. Now we need to simplify further. What if I divide both sides by x, thereby making the right hand side to be equal to 1? Will that make sense? Let's see what we'll do. If we divide here by x, then I'll divide here by x, x will have to cancel out x, and then I'll have the exponent value of x divided by 2 divided by x, and this will be equal to 1. Now, what do I do from here? I still have to simplify. And for me to simplify, I need to find a common ground. And for me to find a common ground, I'll have to expand this. Now, this is going to give me 1 divided by x multiply the exponential value of x divided by 2, and this will be equal to 1. I didn't change anything. I just separated the fraction from the normal expression. Now, what I need to do now is to mend this expression such that it looks like the Lambert W function expression. Now, how do I do that? Let me see the need of multiplying both sides by -1. I'll multiply both sides by the power of -1. If I multiply both sides by the power of -1, that means this whole expression, 1 divided by x multiplying x to the power of x divided by 2, will all be multiplying -1, right? And then I will be having this 1 to the power of -1. Now, what am I driving from this? From this expression, I can find this whole expression, 1 divided by x to be to the power of -1, right? And then this will multiply the exponential value of x divided by 2, and all of this to the negative to the power of -1. And this definitely will be equal to 1, because 1 divided by 1 to the power of 1 is still equal to 1. Good. Now I can simplify this whole expression. If I simplify this whole expression, what is it going to give me? It's going to give me x, because I'm going to have, if I have 1 divided by x all to the power of -1, this is exactly going to give me x to the power of -1, and it's going to multiply -1. Negative cancels out to give me positive, and then this is going to give me x. So that means this whole expression here is simply going to give me x multiplied by, this is going to give me the exponential value of -x divided by 2, and that will be equal to 1. Great. Now let me simplify that further. If I simplify that further, I'm going to make that expression more simpler and amend it such that it looks like the Lambert W function expression. Now, how do I do that? If I reduce that expression, I'm going to have that expression to become x multiplied by the exponent value of negative x divided by 2, and that is equal to 1. That is the expression we have come out with. Now, having seen this expression, I want us to look at the way we can mend this expression in order to get the Lambert W function. Now, the only way we can do that is to multiply both sides by an expression to make this look like what is here. And what do? I have to multiply both sides by negative minus half. Now, if I multiply both sides by minus half, I'm going to arrive at a given expression. Now, let me look at negative 1 divided by 2 multiplied by all these expressions. Negative x divided by 2. And remember, whatever I do to the left hand side, I'll always do that to the right hand side. And this will be equal to 1 multiplied by the negative 1 divided by 2. So this whole thing on the right hand side will give me negative 1 divided by 2. And then this whole expression will give me negative x divided by 2 multiplied by the exponent value of negative x divided by 2. Now, do you see something? That this is similar to this, and that is exactly what we want to arrive at. Now, remember the Lambert rule. The Lambert rule said if we have the Lambert of a given value a multiplied by the exponent value of a, that this simply is equal to a. So what does that tell us? That tells us that we need to take the Lambert of that expression. And this whole expression just stands like this. And then if we take the Lambert of this whole expression, that means the only thing we'll be having here is negative x divided by 2. And this will be equal to the Lambert of this expression, right? And that will give us the Lambert of that expression, negative 1 divided by 2. Right? Great. Now, what do? We have to simplify. And to simplify, we have to multiply both sides by negative 2. And that will help us clear the negative, the 2 and the negative sign here. So if I multiply here by negative 2 multiplying negative 1 divided x divided by 2, right? And this will be equal to the Lambert of negative 1 divided by 2 multiply negative 2. Why the negative cancel out the negative? The 2 cancel out 2. Negative multiplied by negative is simply going to give us s, and that is all. So that x value is going to give me that expression to become what? Negative 2 Lambert of negative 1 divided by 2. And that seems to be the value of our s. So the value of our s that satisfies this expression is going to be x equal to negative 2, the Lambert of negative 1 divided by 2. Now, if this seems to be the answer to that question, then it can be the right option, because this can definitely suit this expression compared to that initial expression we have, in which we have only the exponent of x divided by 2 equal to x, because we still have a value of x in the other side of the expression. So if you do have anything concerning this solution, I do want you to drop your comment in the comment section. Now let's analyze one final question. Most of the time comes out in most of these examinations I've mentioned or I've discussed about. And what is that common question? Is one common question that is logical and that needs the application of a lot of principles in mathematics in order to bring such questions down. And what is that question? If we are given the third power of s, the 4 to the power of x equal to 30, questions like this, and you are asked to find the value of x, what will you do? This is another big question that many students find very difficult. You know why? Because most of the time, whenever questions like this are given, most students will want to say, okay, let me quickly find out a common base. And while the common base cancel out the common base, then the power or the index can equate, and then that becomes the solution. Of course, that can be possible if this can give you a common base to this. But if it cannot, that is where the more effort and logical reasonings have to come in. Now, 30 cannot be expressed in a common base of 4 or 2. I can decide to say, okay, let me have 2 to the power of 2, which is going to give me 2s. I can never have a 30 of base 2 or base what? Or base 4. So that means this expression cannot be used. So what do I do? The only solution to questions like this is to apply your natural laws of logarithm, or you use the law of logarithm or the natural law of logarithm. Now, how do we play around with that? Let's look at that. We're going to take the log of this other side, which is the log of 4 to the power of x, right? And that will be equal to the log of 30. Now, from that expression, you come to see that I can separate 30 to 60 times 4, right? 6 times 4 can give me what? Can give me 30, right? So if I look at that 6 times 4 can give me 30. So I can simply, 6 times 5 can give me 30, right? Great. So 6 times 5 can give me 30. So I can easily break down that expression to give me 6 times 5. Yes. So if, according to the law of logarithm, this can easily come over here. And then we'll have our x log of 4 to be equal to the log of 6 multiplied by 5. And that is equivalent to 30, right? And that is that. So if we look at that expression very well, it's getting us somewhere. All we need to do is to divide both sides by the log of 4 and divide here by the log of what? Log of 4. While the log of 4 cancel out the log of 4, we're going to have our x to now be equal to the log of 6 plus the log of 5. And all of these will be dividing the log of 4. Now remember the multiplication law of logarithm. Now when you have this multiplying this, they simply separate with an additional sign. So we can separate this expression to give us the value of our x to be equal to the log of 6 divided by the log of 4. And this can be plus the log of 5 divided by the log of 4. Great. Now, do you know that this can also be broken down? And then I'll have my x to be equal to the log of, this can become 3 multiplied by 2, right? And all of these can divide the log of 4. While this can be plus the log of 5 divided by the log of 4. Great. Now, what do we do from here? We can simply break out this, applying still the multiplication laws of logarithm. Now, if I apply the multiplication law of logarithm, I'll have that expression to be x equal to the log of 3 plus log of 2, all divided by the log of 4, right? And this can be plus log of 5 divided by the log of 4. Great. Now, if I simplify that, I'm going to have that expression to a more reduced term. Now, if I have that expression to a more reduced term, I'm going to have the value of my x to now be equal to the log of 2 divided by the log of 4 plus log of 3 divided by the log of 4 plus the log of 5 divided by the log of 4. Now we can reduce 4 because 2 to the power of 2 can still be equal to 4. And according to the law of indices, we can have this to become x equal to the log of 2 divided by log of 2 to the power of 2 plus log of 3 divided by the log of 2 to the power of 2, or 2 base 2, and this will give us plus log of 5 divided by the log of 2 to the power of 2, which is still representing 4. Now, according to the law of logarithm, this can come over here, and then we'll have our x to be equal to 1 divided by 2 log of 2 divided by the log of 2, right? Plus, this will also become 1 divided by 2 log of 3 divided by the log of 2, right? And this can be plus 1 divided by 2 log of 5 divided by the log of 2. Great. Now log of 2 can cancel out log of 2, and we have half, half, half common, and so we'll bring out the half, 1 divided by 2, and this will give me what? 1 plus log of 3 divided by the log of 2 plus log of 5 divided by the log of 2. Great. Now remember one great law of logarithm, that if I have the log of A dividing the log of B, this can simply give me the log of A base B, right? The denominator becomes the base, while the numerator becomes the log. Now I'm going to apply it here, and I'll equally apply it here. If I do that application, I'll now have that solution to become the value of x will now become 1 divided by 2 to the power of multiplying 1 plus this becomes the log of 3 base 2 plus the log of 5 base what? Base 2. And this becomes the solution to the value of x for that expression given to us. So you see, this is exactly how you solve questions like this. Step by step, you can equally or easily get the solution to that question. Now let's check out to see if our solution is right. I'm not going to leave it that way. I'm going to check out to find out if our solution is actually right. So what I'll do is to insert the value of x, which I've gotten over there, into the main expression that is given to me. Now if I do that, you will see that I'm going to have a given expression. Now if you are enjoying this live class, just drop your comments and let me know your opinion as regard most of these questions we are solving, and I will be so delighted to have an interaction with you. Now let's look at that. I'm going to insert this expression, which is the log of s equal to half of 1 plus log 3 base 2 plus log 5 base 2. That expression can simply make my x to be equal to 1 plus log of 3 base 2 plus log of 5 base 2, all divided by what? By 2. And this will become my solution. Now let me insert this whole solution as a value of x into this expression. Will it give me 30? Let's try that out. So we have 4 to the power of 1 plus log of 3 base 2 plus log of 5 base 2 all divided by 2. Is it going to give me the solution 30? Now remember, 4 can be 2 to the power of 2, and then 2 will multiply this whole expression, 1 plus the log of 3 base 2 plus log of 5 base 2 and all divided by 2, right? And will this be equal to 330? Remember, from this expression, this will cancel out this, right? And then we'll have 2 to the power of 1 plus log of 3 base 2 plus log of 5 base 2. Now will this expression give me 30? Let's find out. Now remember one law of indices. If I have a to the power of x plus y plus z, this can simply be equal to a to the power of x multiplied by a to the power of y, right? Multiplied by a to the power of z. Now if I expand this expression to that extent, or to with that laws of indices, I'm going to have that expression to now give me 2 to the power of 1 multiplying 2 to the power of the log of 3 base 2 multiplying 2 to the power of the log of 5 base 2, and will this be equal to 30? Now recall one great law of logarithm, that if you have a to the power of the log of x base a, this can simply be equal to a, right? Because this can simply be equal to x, right? Because a will cancel out a, and then x will give us the solution. Now if we check out that, comparing that with this, you find out that 2 will have to cancel out 2 over here, 2 will have to cancel out 2 over here, and then I have 2 to the power of 1 multiplying, right, 3 multiplying, right, 5, and this will be equal to 30. Will this give me 30? 3 times 2, 2 times 3 is going to give me 6 multiplied by 5. 6 multiplied by 5, will it give me 30? Of course, yes. So 30 is actually equal to 30. So that tells us that this expression here is the value of x that satisfies our question given to us there. So you see, that's how you solve questions related to exam questions related to things like this. So in today's class, we've succeeded looking for answers to 3 important questions you might most likely see in your Olympiad Maths exams, your Oxford exam, advanced maths exams or entrance exam tests or aptitude tests, your Harvard exams, and some other exams you might be taking. And what are those questions? We isolated 3 questions. And what are those questions? 1, we looked at a question that if you have the 4th root of x, the 4th root of x equal to -4, and you are asked to find the value of x, right? That's the first question we analyzed. And then in the second question, we analyzed the number 2. We analyzed the exponential value of x equal to x to the power of 2, and we are asked to find the value of x, right? And then in the third question, we are also analyzed 4 to the power of x equal to 30, and then we are asked to find the value of x. So if you are given any question like this, then you should be confident enough after watching this live class to tackle it. So these are some of those typical of questions you might see in your exams. Now I want you to put up that confidence. Whenever you see questions like this, don't forget to look at the steps we've taken, use such steps and such principles we have applied to solve such question. If you did enjoy this live class, don't forget to join us in our subsequent live class, as we'll be considering some other most likely questions you might most likely see in exams, in those exams we've mentioned. And I'm going to take you through some of those questions that was given in your previous CA Olympiad 2024 Olympiad exams. What are some of those questions? And then we'll look at how we can brainstorm on such questions to find solutions to such questions. Now, if you do like this live class, do subscribe to our channel for subsequent notification of our live class whenever we go online. I do appreciate your staying with us, and I want to say a big thank you to all those who stood by us throughout the course of this live class, and I know you've truly learned a lot. Thanks so much for being with us, and I look forward to seeing you in my next live class. Thank you, and bye-bye for now.